Hi guys, welcome back to Your Head Smart. I hope you guys doing good. So chapter 6, we're going to see escalation privilege this video. Okay, we have already completed 5 chapters. So if you guys missed any of these ones, please go and watch these to get better understand. Okay, so privilege escalations. During a penetration test, we often gain an initial foothold on a system as a standard or non-privileged user. In this case, our next step is to gain additional access rights to demonstrate the full impact of the compromise. This process is referred to as privilege escalation, and it is a necessary skill as direct to root compromise, or rare in modern environment. While every target can be considered unique due to difference in OS versions, patch levels, and various other factors, there are some common escalation approaches. To take advantage of these, we will search for misconfigured services, insufficient file permissions, kernel vulnerabilities, and vulnerable software running with high privileges. To name a few, we can see information gathering. After compromising a target and gaining the initial foothold as an unprivileged user, our first step is to gather as much information about our target as possible. So this allows us to get a better understanding of the configuration of the machine we have compromised and discover possible privilege escalation vectors. So in this video, we will explore both manual and automated information gathering and enumeration technique. Manual enumerations. Manually enumerating is a system can be time consuming. It does, however, allow for more control and can help identify certain rare privilege escalation methods that are often missed by automated tools. To demonstrate all the commands, we will do SSH as a non-privileged users to both Ubuntu and Windows machine, my test machine. So this is Ubuntu machine. So here we can now connect the Windows machine. Okay, it takes some time. Okay, enumerating users. When gaining access to a target, one of the first things we should identify is the user we are running as. The whoami command is a good place to start because it is available on both Windows and Linux. When run without arguments, whoami will display the username the shell is running as. So you guys can see here the username, and then on Windows, we can gather more information by passing the discovered username as an argument to the netuser command. So we can use the student. The output indicates various information including the user we are running as student and the group we belong to. So you guys can see here. Okay. So we can now check the Linux machine. On Linux based systems, we can use the id command. Okay, so we can use the id command to gather information about the current user. The output reveals that we are running as the student users, which has a user's identifier and then a group identifier of 1001. So to find other users accounts on Windows system, we can run the netuser. So let me show you that. So this is, most of you already know. So currently the test machines, I can see that I have only the 2 accounts, administrators and student. To enumerate users on a Linux based system, we can simply read the contents of the etc password file. Let me show you that. So most of you guys already know this. Okay. So the password file contains several users accounts including account used by services on the target machine such as www data, which suggests that a web server may be running on this machine, something like this. Okay. Enumerating all users on a target machines will help identify high privilege users accounts we could target to elevate our privilege. Enumerating the hostname. The hostname of machine can often give clues about its roles because it often includes abbreviations such as web for a web server or DB for a database server. So we can find the hostname with the hostname command, which is available on both Windows and Linux. Let's first run it on Linux machines, OpenDOM machine. So this hostname of the Linux client provide us with the information about the OS it is running. So now let's see on Windows machine. So the Windows client has a fairly generic hostname. Identifying the role of a machine is useful for focusing our information gathering effort. So now we can see enumerating the operating system versions and architecture. At some point during the privilege escalation process, we may need to rely on kernel exploitations that exploit vulnerabilities in the core of a target operating system. This type of exploits are built for a very specific operating systems and versions. Since attacking the target with the wrong kernel exploit can cause us a system crash, we must identify detailed information about the target. On the Windows operating system, we can use the system info utilities or system info, as you guys can see here. Okay, so you can use the system info to find the operating system and architecture information. We can also filter the output using find string along with a few useful flags. Specifically, we can match patterns at beginning of a line with /b and specify the search string with the /c. We will search for the name of the operating system and its version, you guys can see here, and its architecture system type. Okay, so we can now enter. So this system is running Windows 10 Enterprise version 10.0.19041, and then architecture is x64 based PC. So on the Linux machines, it issues the release files located in the etc directory contain similar information. So let me show you that. Okay, so we can also use these command. We can also use these. Okay, so we can also use the uname-a command to find the kernel version and architecture. So let's say, okay, now let's take a look at running processes and services. If a process runs in the context of a privileged account and has insecure permissions or allow us to that are part of a specific Windows services. So here you guys can find the services that are running. On Linux machine, we can list all system processes including those run by privileged users with the ps command. So now we can see enumerating networking information. The next step in our enumerations of the target host is to review its networking configuration. On Windows machine, we can begin our investigations on the Windows client with the ipconfig using the /all flag to display the full configuration of all adapter. To display the networking routing tables, we can use the route command followed by the print arguments. So let's enter. Finally, we can use netstat to view the active network connections. So similar commands are available on Linux. Depending on the version of Linux, we can view the TCP configuration of every network adapter with either ifconfig or IP command. So both commands accept the flag to display all information. We can display the network routing tables with either route or route. So finally we can display active network connections and listening port with either netstat or SS. So let's say I'm using SS ANP. So both of which accept the same argument, enumerating firewall status and rules. Generally speaking, a firewall's config exploitation phase of an assessment. However, this information can be useful during privilege escalations. For example, if a network service is blocked by the firewall and not accessible remotely, it is generally still accessible locally through the loopback interface to facilitate port forwarding and tunneling when it's time to pivot to internal network. On Windows, we can look at the current firewall profile using the netsh. In this case, the current profile is active. So let's have a closer look at the firewall rules. We can list firewall rules with the netsh command. Specify that we want to show all rules. So we can list the firewall rules with the netsh command. Specify that we want to show all rules. Keep in mind that not all firewall rules are useful, but some configuration may help us expand our attack surfaces. Unfortunately, on Linux-based systems, we must have root privilege to list firewall rules. Enumerating scheduled tasks. Attackers often target scheduled tasks in privilege escalation attacks. Systems that act as server often periodically execute various automated scheduled tasks. This scheduling system can sometimes have confusing syntax, which can cause misconfiguration or leave user-created file with insecure permissions. With the sch task command, we can create and view scheduled tasks on Windows. So with this command, with the sch task command, the /query argument displays tasks, and to the list output as a list we can add the /fo list argument. We can also use /v for verbose output. Okay. The Linux-based job scheduler is known as cron. Scheduled tasks are listed under a set of directory under /etc organized based on the frequency the task will run. Let's say the cron jobs are typically located in this pool directory. They are stored in the tables called cron tabs. These tasks, as most of the jobs in the particular file, will run as a root. So because if the file has a weak permissions, we may able to use the escalate our privileges. Enumerating installed applications and patch level. At some point we may need to use an exploit to escalate our local privileges. If so, we need to enumerate all the installed application and the versions. So this command is very powerful. It will automate the process on Windows systems. So let's say here WMIC with the product WMI class argument followed by get. Here you guys can see here. Okay, so it to read installer of the hotfix ID and installed on information can provide us with a precise indication of the OS patch level. So as you guys can see here, the hotfix ID. Linux-based systems use various package managers. For example, Debian based Linux distribution use D package while Red Hat based system use RPM. To list application installed by D package, we can use dpkg-l. Let's say pkg-l. Okay, here you guys can narrow down the file, the application. Okay, enumerating readable or writable files and directories. As we previously mentioned, files with insufficient access restrictions can create a vulnerability that can be used to elevate our privileges. So this can happen when script or binary file can be modified, which are then executed under the context of privileged account. It might also be possible for unprivileged users to read sensitive files that may contain important information. Since manually checking the permission of each file and directory is not feasible, we need to automate these tasks as much as possible. There are a number of utilities and tools that can automate these tasks for us on Windows platform. Access check from sysinternals is one of the most well-known and often used tools for the purpose. So you guys can download the sysinternal suite from Microsoft website. So we can use the accesscheck.exe. We will use it to find a file with insecure permissions in the program files directories. Specifically, we will check the program file directory for any file or directory that allows the everyone group write permission. So we will use U to suppress error, and the W to search for write access permissions, and S to perform a recursive search. Okay, so we can now enter. So at the moment I don't have, so when I enter no match object found because I don't have any sample right now. If there is any match found, it will show here in the no matching objects found. Here you should be able to see the matches if there is any. Okay. On Linux operating system, we can use the find command to identify files that insecure permissions. Let's search for every directory writable by the current user. We will search the whole root directory with / and use the -writable argument as you guys can see here. So the -writable argument to specify the attribute we are looking for. We can also use -type D to locate directories, and we will filter error to make the output easier to read. Okay, so let's enter. With this output, you guys can easily find the which directory is writable on the file, so all the information. Okay, enumerating unmounted disks. Usually drivers are automatically mounted at boot time. It can be easy to forget about unmounted drives and the valuable information they may contain. So we should always look for them. On Windows-based system, we can use mount wall to list all drives that are currently mounted as well as those that are physically connected but unmounted. So we can use this command mount wall, enter. So here you guys can, so here the output you guys can see that the output you guys can see the current mount points. So here the C and D. Okay, here we also notice that we have a volume that has no mount point. So this could be interesting and we might want to take a closer look at it. Okay, so on Linux based machine, so you guys can use the mount command to find all mounted file system. In addition, you guys can also use cat etc and fs tab file. This contains information about all drives mounted at boot time. So the output reveals a swap partitions and the primary extension for ext4 disk of the Linux system. So we can also use lsblk command. So we notice that the SDA drive consists of their different partitions which are numbered. In some situation we might find partitions that are not mounted. Depending on the system configuration, we might be able to mount those partitions and search for interesting information that could allow us to escalate our privileges. Enumerating device drivers and kernel modules. We can also escalate our privileges by exploiting device drivers and kernel modules. Since the techniques relies on matching vulnerabilities with the correct exploit, we will need to enumerate all the loaded drivers and kernel modules. On Windows, we will use the driver query command to help gather this information. Okay, to filter, we use the PowerShell. To filter the output, we will use the run the command inside a PowerShell session. On Windows, we will use the driver query command to help gather this information. So to filter the output, we will run the command inside a PowerShell session. The /v, as you guys can see here, the /v argument will produce verbose output, and /csv requires the output in CSV format. Next, the dash. Next, we pipe the output to the convert from CSV. Okay, and then commandlet as well as select object, which will allow us to select specific object property such as display name, start mode, and path. Okay. So let's enter. While this produced a list of loaded drivers, we must take another step to find the version number of each one. On Linux, we can enumerate the loaded kernel module using lsmod. So once we have list of loaded module and want more information about one like SND or any of these, okay, you can use the sbin mode info to find more info about SND. Okay, please note that this tool requires a full path name to run. After obtaining a list of drivers and their versions on Windows or Linux, we can look for exploit targeting these drivers. Automated enumerations. Each operating system contains a wealth of information that can be used for further attacks. However, collecting the detailed information manually can take a lot of time. Fortunately, we can use various scripts to automate this process. On Windows, one such a script is Windows Priv check. So you guys can get download from online. This Windows Priv SC, and then you can use -h the help page. You can find more options there. Let me show you that. Okay. These tools accepts many options. Let's list information about the user groups on the system. So we will use the -dump to view output and -g to list groups. Okay, let's enter. So here the script successfully executed and provide us with the information about the group, as you guys can see here, the bottom, and the group on the systems. So similar to the Windows previous queue check tool on Windows Target, we can also use Unix previous check on Unix derivatives such as Linux. We can get download from online. So you don't need to add -h to see the help page. You can just enter. According to the help menu, the script support standard and detailed, as you guys can see. Okay, the standard mode appears to perform a speed optimized process. Here you guys can see. So we will use the standard mode and redirect the output to a file called output.txt. So let me show you that. So this script performs numerous checks for permissions on common files. For example, the following section reveals configuration files that are writable by non-root users. So let's enter. So we can now, so here you guys can see the warning that etc password. So anyone can, so this shows that anyone on the system can edit the etc password file. So this is quite serious because it allows attackers to easily elevate their privileges or create users accounts on the target. Although this tool performs many automated checks, keep in mind that every system is different and some system changes will often be missed by this type of tools. For this reason, it's important to watch out for unique configuration, which can only be caught by manual inspection. Windows privilege escalations examples. In these sections, we will discuss Windows privilege integrity mechanisms and users account control or UAC. We will demonstrate UAC bypass techniques and leverage kernel driver vulnerabilities, insecure file permissions, and unquoted service paths to escalate our privilege on Windows. Understanding Windows privilege and integrity level. Privileges on Windows operating systems refers to the permissions of a specific account to perform systems related action such as modifying the file system, adding users, shutting down the system, and so on. For these privileges to be effective, Windows uses object called access tokens. Once a user is authenticated, Windows generates an access token that is assigned to the users. The token itself contains various pieces of information that describes the security context of the users, including the user privileges. Tokens need to be uniquely identifiable. Depending on the information they contain, this is done using a security identifier or SID, which is a unique value that is assigned to each object, including tokens, user account, and group account. In addition to privilege, Windows also implements an integrity mechanism. This is a core component of the Windows security architecture and works by assigning integrity levels to application process and secureable objects. In other words, this describes the level of trust the operating system has in running applications and dictates what actions an application can perform, including the ability to read from or write to the file system. Introduction to user account control. UAC, user account control, is an access control system that forces applications and tasks to run in the context of non-administrative account until an administrator authorizes elevated access. In general, the effect of UAC is that any application that wishes to perform an operations with a potential system-wide impact cannot do so without the user consent, at least in theory. It is important to point out that UAC has two different modes, credential prompt and consent prompt. When a standard user wishes to perform an administrative task, such as installing a new application, the user will be prompted to enter the credential of an administrator in order to complete the task. When an administrative user attempts to do the same, he or she is presented with a consent prompt, and the user simply has to confirm that the task should be completed. Okay. In this case, no re-entry of credential is required, even while logged in as an administrative user. The account will have two security tokens, one running at a medium integrity level and the other at a high integrity level UAC. To see integrity level, we can log in as an administrator and you can open command prompt and run this command, who am I / and group S. So you guys can see here, so these commands, the command prompt in the bottom of the screen is currently running at a high mandatory level. Okay. So let me change this high to medium. So the UAC act as the separation mechanism between these two integrity levels. To see integrity levels in actions, let's first log in as an user, the standard user, and then we can now run this command, who am I and groups. So we can now see here the medium mandatory level. So we can now try to change password here. One, two, three. So here the request is denied because to change the student user password, we must switch to high integrity level. Even if you are logged in as an administrator user, one way to do this is through PowerShell.exe with start process commandlet and specifying the run as administrator options. So here we can now check again the integrity level. Here you guys can see high mandatory level. Okay, we can now try to change password. This time it is completed successfully. The password has changed successfully. User account control bypass case study. There are various ways to bypass UAC. In this example, we will demonstrate a technique that allows an administrative user to bypass UAC by slightly elevating the integrity level. Most of the public known UAC bypass technique target a specific operating system version. In this case, the target is our test machine client running Windows 10. The build is 19041. So here we will use an interesting UAC bypass based on fodhelper.exe, a Microsoft application that runs a high integrity and is responsible for managing language changes in the operating system. We can leverage this to bypass UAC because of the way fodhelper interacts with the Windows registry. More specifically, it interacts with registry key that can be modified without administrative privileges. We will find and modify these registry keys to run a command with high integrity. So let's begin our analysis by running fod helper.exe binary. To gather the detailed information regarding the fod helper integrity level and the permission required to run this process, we'll inspect this application manifest. The application manifest is an XML file containing information that lets the operating systems know how to handle the program when it started. We can inspect this manifest with the sigcheck utility included in the sys internal suites. Okay, so passing the dash argument for extended information and the dash m argument to dump the manifest. Okay, so let's enter. So a quick look at the result shows. So a quick look of the result shows that the application is meant to be run by administrator user. So as you guys can find here, the privilege request privilege. Okay, so it will require the full administrator access token, and then the auto elevate tool, as you guys can see here, the auto elevate flag is also set to true, which allows the executable to auto elevate to high integrity without prompting the administrative users for consent. So next we will use the process monitor tool. We will use process monitor from the sys internal suite to gather more information about this tool as it executes. After starting procmon.exe, we will run fodhelper.exe again, and we will set filter to focus on the activities performed by the process. So this filter significantly reduce the output, but for the specific vulnerability, we are only interested in how this application interacts with the registry key that can be modified by the current user. To narrow our results, we will add another filter with a search for reg, which Procmon uses to mark registry operations. Operations contains and reg. Once our additional filter has been added, we will run the fodhelper.exe again. And we should only see result for registry operation. These are more manageable, but we want to further reduce the output. Specifically, we want to see if the fort helper applications is attempting to access registry entries that don't exist. If this is the case and the permission of the registry keys allow it, we may be able to add those entries and change these actions that target high integrity processes attempting to perform. This time we will add a result filter for name, not found, an error message that indicates that the application is attempting to access a registry entry that doesn't exist. So result, this one is contained, leave it as it is. Name not found. Then add, then apply. So this output reveals that the fort helper.exe does in fact generate the name not found error, an indicator of a potential exploitable registry entries. However, since we cannot just modify registry entries in every hive, we need to focus on the registry hive we can control. In this case, we will focus on this HKey current user HKCU hive, which the current user has the ability to modify. Path and then KCU add apply. Now click OK. So just expand it. This is rather interesting. FortHelper.exe attempts to query a registry key that doesn't appear to exist. To understand why this is happening and what exactly this registry key is used for, we will modify our path filter and look for any access to entry that contains ms setting shell open command. Okay. This is rather interesting. FortHelper.exe attempts to query a registry key that doesn't appear to exist. To understand why this is happening and what exactly this registry is used for, we will just modify our path filter and look for any access to entries that contain ms settings shell open command. So we can just scroll up a little bit, filter, path. We can just copy this path. If the process can successfully access that key in some other hive, the result will provide us with more clues. So we will also remove our result filter. So we can now remove the. So this is an interesting key you guys can find here. When Fort Helper doesn't find the registry key in HKCU, it immediately tries to access the same key in the HKey class's root hive, and it is successful since the key exists. So we can now just copy the shell. We can just copy the entries. So let's say just copy here. And then we can now open registry and try to find it in the registry. Just copy here. So we can now search this key in the registry. HKey. Source. Root. So enter. If we search for this key in the registry, we manage to find a valid entry. Based on these observations, after searching the MSDN documentations, we can filter the Fort Helper is opening a section of the Windows settings application through the MS setting application protocol. An application protocol on Windows defines the executable to launch when a particular URL is used by a program. So let me show you here. You guys can find the information here. Okay. So this URL application mapping can be defined through registry entries similar to the MS setting key we found in HKCR in this case. So this URL application mapping can be defined through registry entries similar to the MS setting key what we found in. This URL application mapping can be defined through registry entries similar to the MS setting key we found in HKCR. In this case, the application protocol schema for MS setting passes the execution to a COM object instead of to a program. So this can be done by setting the delegation execution key value to a specific COM class's ID. This is definitely interesting because fault helper tries to access the MS settings registry key within HKCU Hive. First, previous result from process monitor clearly showed that this key doesn't exist in HKCU, but we should have the permission to create it. So this could allow us to hijack the execution using a properly formatted protocol handler. So let's try to add the key with reg utility. Okay, so we can now enter. So the registry key is added successfully. Once we have added the registry key, we will add our result filter again. So now click OK. So now we can clear the process monitor. Okay. So we can now restart the fault helper.exe. So we can now monitor the process monitor. This time, fault helper.exe attempts to query a value called delegate executive stored in our newly created command key. So normally you guys can find that C small capital. Okay, and then here there is a 2 entry. So this didn't happen before we created our fake application protocol key. However, since we don't want to hijack this execution through a COM object, we will add an empty delegate execute entry. However, since we don't want to hijack the execution through a COM object, we will add an empty delegate execute entry. The plan is that when fault helper discovers this empty value, it will look for a program to launch specified in the shell. The plan is that when fault helper discovers this empty value, it will look for a program to launch specified in the shell open command default key entry. We will use regadd with the /v argument to specify the value name and then /t to specify the type. Okay, enter. In order to verify the fault helper successfully access the delegate execute entry we have just added, so we will now remove the name not found filter. So let's say open the proc mode. filter. So we can just replace the success. Okay, and then add. Apply. Click OK. So we can now restart the process again. So open command prompt. Enter. As expected, for helpers find the new delegate execute entries we added, but since its value is empty, it also looks for the default entry value of the shell open command registry key. The default entry value is automatically set to null when adding any registry key. We will replace the empty default value with an executable of choice command.exe. So this should force port helper to handle the MS settings protocol with our own executable. To test this theory, we will specify the new registry value with /d command.exe. So let's see. So to test this theory, we will specify the new registry value with the /d command.exe and use the /f to add the value. Okay. After setting the value silently, and we can run the fort helper exe again. After setting the value and running fort helper.exe once again, we are presented with the command shell. Okay. So we can check this who am I and groups to check the integrity level. So here you guys can see that high mandatory level. Okay, now we can change. Now we can try to change the password. Okay, now it's successful, and we have now successfully bypassed UAC. So this attack not only demonstrates a terrific UAC bypass, but also reveals a process that we could use to discover similar bypasses. Okay. Understanding Linux privileges. First, let's take a moment to briefly discuss Linux privileges, access controls, and users. One of the defining features of Linux is that most resources including files, directory, devices, and even network communications are represented as files in the file system. In other words, everything is a file. Every file has three basic permissions: read, write, and execute. Insecure file permission cron. Case study. We will first demonstrate using insecure file permission to escalate our privileges. For the purpose of the example, we will SSH to our dedicated OpenDoc client machine. Okay. In order to leverage insecure file permission, we must locate an executable file that not only allows us write access but also run as a privileged user. On a Linux system, the cron time-based job scheduler is a prime target, as many jobs are executed with the root user privileges, and system administrators often create scripts for cron jobs with insecure permissions. We could use the technique discussed earlier to locate cron job, or we can inspect the cron logs files for running job. So we can now run the script. So the result, it appears that a script called test.cron.sh I have created for testing purpose. It runs every 1 minute, every 60 seconds. Okay, so as a root user, and judging by the timestamps, it runs once every 1 minute, since we know the location of the script. So let's inspect its contents and permissions. So the script itself is fairly straightforward. It simply copies the student user home directory to backups and subdirectories. Okay. So now let's check the permissions. So as you guys can see, the permission of the script shows that any user can write to the file, since an unprivileged user can modify the contents of the backup scripts. Okay, so we can edit the script and add a reverse shell one-liner. So if our plan works, we should receive a root level reverse shell on our attacking machines after the 1 minute at most. If our plan works, we should receive a root level reverse shell. So we can now set up the listening port 4444. So after 1 minute is now connected, so we can now check who am I. Okay, so you guys can see here the root. Okay, so we have now successfully elevated our privileges and have access to a root shell on the target. Although this was a simple example, we have encountered several similar situations in the field because administrators are often more focused on cron's add syntax than on file permission for the scripts. Okay, so that's it guys for this video. So we will see that one more topic, the last video. So I will upload it in the next few days or week. Thank you for your support. Stay safe and healthy. Bye bye.